Well, here we go, folks. Welcome back. If you're watching this video, you have accessed today's lesson through Google Classroom. Hopefully you've read today's goals and you've already watched the student energy vid on geothermal energy to help familiarize yourself with the topic. What we're looking to do right now is take a few notes on geothermal energy. Hopefully you've saved this note sheet to Notability, and you can follow along with me here. Pause the video and fill in your note sheet as we go. And as always, any questions about any of this stuff, just shoot me an email. I'm here today, I'm waiting, and I'll answer any questions you may have. Just give me a shout. So let's talk geothermal energy. Pretty cool stuff here. This whole source of energy is based on the idea that the internal workings of the Earth are real hot, and we already knew that. We talked about how the Earth's structure is based upon 4 layers, essentially. We've got our inner core in here, which is made of solid iron and nickel, and then we had our outer core right here, which is liquid, our outer core, which is liquid iron and nickel, all really, really hot stuff. And then we've got our mantle here, which is our thickest layer of the Earth. That's made of that rock that's also really hot, and it's so hot it's in that state of matter we call plastic, where it can kind of flow, but it's under immense pressure, so it's not melted. And then we live on this super thin layer out here on the edge, the crust, right? So the idea of this geothermal energy is there's lots of heat here deep within the Earth that's working its way outward, and in certain parts of the planet we can access that heat, and we know heat is a form of, essentially is thermal energy. If we can harvest that thermal energy and we can convert that through various forms to electrical energy, we're good to go. So let's talk about just how we go about doing that here at a geothermal power plant. Let's talk about our energy conversions first. Deep down in the Earth here, we have hot water, or just really hot rock, essentially, that we can pump water down and or superheated water in the water table. And we know that hot water is going to contain thermal energy. That's our first form of energy on our geothermal power plant. Obviously, geothermal, we're harnessing that thermal energy from the Earth. Now, just by drilling that well down in there and giving that hot water a chance to expand and become steam, that water is going to begin to flow upward out of that pipe to an area of lower pressure, and now we can see right here we've got water flowing really fast, or actually we have steam flowing really fast up out of the ground, which is going to be mechanical energy. So we've got our conversion here. Now we've gone from just super hot water in the Earth, we've allowed it to become steam and begin flowing, and now we've got mechanical energy flying up through this pipe. We've all seen the steam turbine at this point. We know this deal. This is identical to a coal or biomass power plant, our nuclear power plant. The whole goal of all these different energy transformations is all about creating fast-flowing steam to spin a steam turbine. So again, we've got mechanical energy in our spinning steam turbine, which is transferred to our generator, which is essentially just another example of mechanical energy, right, in our spinning generator. And we all know that our final outcome here, the goal of a generator, is to convert that mechanical energy into electrical, right? So really, really similar schematic, similar layout to that, as I said, nuclear and geothermal, biomass, all those power plants where we want a steam turbine to spin a generator. Here we're just we're utilizing the Earth's heat, which is kind of a really cool idea. So let's go down here and take a look at geothermal power. Let's lay out what's going on. In a geothermal power plant, we're going to say we use the heat from the Earth to make steam and spin a turbine. Very, very similar to other places. And we're going to say that this is popular in areas with lots of seismic activity. I'm thinking about like places like Iceland. Even like Hawaii would not be a bad place to make some geothermal power. The goal is you got to have hot rock right near the surface. Maine, not such a good place to be conducting geothermal power. We'd have to drill really, really deep to get to the kind of temperatures that we need to make geothermal energy. But in a place like Iceland or Hawaii with lots of volcanism, holy cow, you don't have to go that deep to have boiling hot rock. And that's all it takes, and you can make some geothermal power. So pretty cool stuff. There's some major advantages here. It is absolutely a renewable source, right? The Earth's heat is always working its way up out of the core. And it's expensive to put in, but nobody's charging you for the heat once the thing's in there. So we could, in a way, call that energy free. Nobody's charging you for the heat from the Earth. And our other advantage here, if we put in a geothermal power plant, this thing is a 24/7 source of energy. It is a great example of a energy source that we can use as a base load energy production. You put in a geothermal power plant, the thing can run 24 hours a day and produce electricity for us all the time. Remember, electricity is a real-time energy source. It's got to be made right now for us to utilize it. And then in terms of disadvantages, as we go through here, we can really only take advantage at certain locations, right? We can only take advantage at areas with the right geology, we'll say. You know, if you happen to live in Iceland, then you're set right up for geothermal power, which is pretty great. But again, here in Maine, it's not really a viable option for us. And actually, in much of the world, you got to have these highly specialized places. Let's look a little deeper into that here. If we check out Google Earth, our best friend here, and we zoom out. Geez, I was zoomed right in on Sebago Lake. I must have been looking at fishing spots here recently. Let's take a look here, though, at some areas with lots and lots of geothermal activity. If we come up here to Iceland, we can see Iceland is located right there on that mid-Atlantic ridge, that area of seafloor spreading, where the Atlantic Ocean is getting wider and wider every year. And Iceland is essentially an area where the mid-Atlantic ridge has broken the surface. It's composed of a whole series of volcanoes, and Iceland is a great example of a place with lots of seismic activity going on, lots of volcanism, and a great place to conduct geothermal power production. Holy cow, over here in Yellowstone, you know, I'm thinking of places with geysers and things like that. Yellowstone is a caldera. It's a hot spot. It's not located near a plate boundary, but plenty of seismic activity in Yellowstone. Hawaii, we know, is another hot spot in the Earth's crust with lots of volcanic activity. But also places like, you know, the Andes Mountains here on the west coast of South America. That's a subduction zone. Look at that trench right there with the Nazca plate sliding underneath the South American plate. Lots of volcanism along the Andes Mountains here. Great opportunities for geothermal power plants. So certain areas, if you're along a plate boundary or you're in a hot spot with lots of volcanism, you've got the option to make some geothermal power. But you got to take advantage of the area with the right geology, and unfortunately, Maine is not one of those places. If you watch closely in that student energy video, they also mentioned that there are small amounts of CO2 produced, small amounts of, we'll say small amounts of greenhouse gas. And that's released through carbon dioxide bubbles in the water that are coming up out of the ground. I would argue probably peanuts compared to burning coal and oil and natural gas to produce electricity. So while, yeah, we're going to make some greenhouse gas, why not acknowledge that it is not nearly as much as burning coal, and would probably help to reduce our global carbon footprint if we adopted a little more of this in areas where we could. So there you have it. You've got geothermal power plants using the heat from the earth to make steam and spin a turbine. It's renewable and free. It's 24 hours available to us, but unfortunately only found in very specific locations with lots of volcanism and seismic activity, and it does release a small amount of greenhouse gas. So what you have here is a great resource to guide you through your assignment today, which is posted under this topic, March. It'll either be March 19th or March, let's see, my maroon days. You guys will be in there on March 24th, I think, with this assignment. You can use these notes to guide you through that assignment, where you're going to plug in the energy types in the correct boxes, what types of energy we see in at each place in this geothermal power plant, and then again you're going to use complete sentences to describe the way we produce electricity using a geothermal power plant. As always, I'm available via email. Shoot me an email with any questions, anything you need, any help. I'm here and willing to help you. So looking forward to getting you guys back in class here in the future. And thank you. I really appreciate your effort with the remote learning. We'll see you soon.